Welcome everyone to another class of ETE 411 Renewable Energy Technology. In the previous class, we have discussed about a topic which was series and parallel connection of PV cells. Okay, we have discussed at length what the connection is, how the module of interconnection works, how intermodule connection happens, and how you can add different amount of PV cells all together. সবাইকে আমার কথা শুনতেছেন এবং পিডিএফটা দেখতে পাচ্ছেন?
Yes, sir.
जी सर।
আচ্ছা। Today we will do some mathematical problems regarding the series and parallel connection of PV cells. Okay. So let's start the math without further ado. Output for parallel and series. The power output of a single cell is not sufficient for any practical use. So to get the useful and required power, the relatively small power output from an individual cell is multiplied by the number of solar cells in an array. The cell's output current is multiplied by the number of cells connected in parallel. Remember these lines. Okay, remember these lines very carefully. এখানে কি বলছে যে the cell's output current is multiplied by the number of cells connected in parallel and in voltage output by the number of cells connected in series. ঠিক আছে, মানে voltage outputটা হলো যে number of cells connected in series আর voltageর ক্ষেত্রে হলো the number of cells that are connected in series, or whenever it comes to the current it will be the number of cells connected in parallel. So whenever I am showing, suppose something like this, that the ns is the number of cells connected in series, np is the number of cells connected in parallel. Now the nt is the total number of cells on the array. Here this term will be as vc. This is the cell output voltage. va is the array output current, IC is the cell output capability, IA is the array output current capability, and so on. And here is PC, cell output power capability, PA, array output power capability. Then we have the following relationship. এখন whenever here comes the relationship, I will ask you to not to memorize these formulas. Just remember by the common sense. How common sense works, just look at here. Look at this example, then you will understand. Example ta dekhen. Let a certain solar cell type have an output capability of 0.5 ampere and 0.4 volt. Okay, let a certain solar type have an output capability of 0.5 ampere and 0.4 volt. Assume that we build an array such cells with 100 cells connected in parallel by 300 cells in series. That means 300 cells are connected in series and there are 100 parallel branches. Okay, 100 cells connected in parallel means there are 100 parallel branches. Okay, so from the previous class we have come to the conclusion. Suppose there are suppose I am noting by this circle, there are 3 cells in series, and suppose there are 3 parallel branch. There are 3 parallel branch. Okay, that means 3 columns and there are 3 rows. So what is the number of total cell? You know, this is some kind of matrix, then you can tell me the number of total cell is a 3 into 3. That means you have to multiply the cells connected in series by the cells connected in parallel. 3 into 3, 9. So whenever you are doing this kind of math, just go to by your intuition. মানে আপনার মানে বুঝার বা আন্দাজের উপর এটা করলে হয়ে যায়. Look at here. The amount of cell that is connected in series is how much? 300 cells in series. And the series connection is applicable. Series connection is responsible for increasing the voltage, and parallel connection is responsible for increasing the current. এই কথাগুলো মনে রাখেন. Series means increasing voltage, parallel means increasing current. So 300 cells in series, what they will do, they will increase the voltage. So here the total array voltage, what will be the total array voltage? Array voltage this is my array voltage, দেখেন ns into vc, again অনেক কিছু করে এগুলা। if you don't use the formula there is no problem, go to by your intuition. Okay, I'm again saying go to by your intuition, don't need to use any formulas here. So there are 300 cells in series, one cells voltage is 0.4 volt and 300 into 0.4, 120 volt. It is like, suppose the price of one apple is 10 taka, then what is the price of 10 apples? Then what you do, you 10 into 10, 100 taka. This is just like that. ওই unitary system এর math এগুলা, ঠিক আছে? 300 cells in series, so 300 into 0.4, answer is 120. Then you want to know the current, then how many parallel cells or parallel branches are there? 100 cells connected in parallel. That means that will be 0.4 into 100. Sorry, 0.5. One cell is 0.5 ampere, 0.5 into 100, 50 ampere হবে। এখানে আসলে পিডিএফ এর মধ্যে একটু লেখা একটু ভুল আছে। This will be ampere. Okay, the current will be here ampere. So the thing I want to show you here is that you just go by your intuition and don't need to memorize this kind of formulas. Okay, this is unnecessary. Now if I ask you that the one PV cell has a voltage of 0.4 volt and current of 0.5 ampere. One PV cell has a voltage of 0.4 volt and current of 0.5 ampere. Then what is the power? What is the formula of the power? We know the formula of power P is equals to VI. Okay, so here my V is 0.4, my I is 0.5. Okay, so whatever may the answer came. So this is also one PV cells power. Now I will ask you that how many PV cells are there in this math? How many PV cells are 100 cells connected in parallel, 300 cells in series? That means it is 100 cell, 300 cells in series. That means 300 rows. 100 cells in parallel. That means 100 column. Then the total amount of cell will be how much? Suppose I can write it like NT, total number of cell will be what? The amount of cells that is in parallel and that is in series. So in series there is 300, in parallel there is 100. So this is my total number of cells. So the power here, and the power I'm showing here 0.4 into 0. This is for one cell, and the total number of cell is this. So the total power of array will be what? 300 into 100. A simple common sense. These maths are built for common sense, not for any hard rules or hard formulas. You can do it just by common sense. 300 into 100.4. This is the total power. You have in this section you have found the power of one PV cell. In this section you have found the power of total PV cells, because this is the amount of cells that is stored in that PV array. Total PV array যে পাওয়ারটা ওটা বের করে ফেলবে। So these are the very simple maths. এই পিডিএফটা দিয়ে দেব, but just I am giving you this question to understand the question. If you don't like this, the solution of it, just go by my intuition. Okay, intuition দিয়ে করে ফেলবে, এটা হয়ে যাবে। ঠিক আছে, 100 cells are connected in parallel, so I multiplied the current by 100. 300 cells in series, so I multiplied the voltage by 300. That's it, nothing more, nothing less. Okay, very simple, very easy. এখানে কোনো প্যাচ গোসের কিছু নাই। So we have completed a math regarding the PV cells connected in series and parallel. Now proceeding to today's lecture. Today we will discuss at length how a solar PV system works, how PV cell from your roof is responsible for giving you the power to run the devices at your home, like TV, like charging your phone, like turning on your router, etc. So the main man of any solar PV system, the main man, Okay, the main figure is what? Is obviously sun, because without sun there the PV module or anything is useless. Okay, সবাই কি আমার কথাটা শুনতেছেন তো?
জি স্যার।
আচ্ছা, আমি জিজ্ঞেস করলে একটু একজন মাইক অন করে রেসপন্স করেন। আচ্ছা, so the main man behind any solar PV system is the sun. Okay, the sun is responsible for starting everything. Without sun there is nothing called the PV system. Okay, photovoltaic system kick started by the sun. Now here you can see that with the help of the sun, the PV module starts to operate. PV module starts to operate, and that PV module is transforming the solar energy into electrical energy. Okay, the PV module is transforming the solar energy into electrical energy. There is many physics behind it. We have seen it. We have seen many things how this conversion happens. Now we can see that PV module can be worked in two types. You can work the PV module directly. You can work the PV module by storing the charge. Sir, why storing the charge is important and why it is necessary for us to storing the charge? There are two aspects of it. There is no sun when it comes to the night part. But if you want to run a house fully by solar power, then you need your current or electricity at night. So what can you do? What can you do is you can charge your charging devices in the daytime and then you can use it in the night time. Okay, so here comes the storage devices, which is termed as energy charger. There are many storage devices like chemical storage, which is known as battery, hydro storage, compressed air storage, flywheel storage, etc. There are many storage devices. These are therefore names. There are many storage devices. So with the help of these devices, you can store your power. Another way is if you want to get the power or if you want the solar power directly from the PV module. Okay, you can do it directly from the PV module. Now, there comes a certain catch. That certain catch is you can't use the PV power directly onto your devices. আপনি সোলার সেলের কাছে গিয়ে মোবাইল চার্জ দিতে পারবেন না, সেলের উপর একটা তার লাগাই দিলে এটা চার্জ হয়ে যাবে না। This is not that simple. So in order to use the PV module, you need some kind of power conversion devices. The power conversion devices is the power electronics devices you have taught in your, I guess 3.2, yes, 3.2. So the power electronics devices that will help you to convert the PV power to your device approximation, okay, or device allocation. Like if you want DC power, then you can use the DC to DC converter. If you want any AC power, then you can use the inverter. So these power electronic devices are very important and integrated part in solar PV system, which you use to convert your PV power into the desired power like AC or DC. Even PV modules are giving you a certain amount of DC power, sometimes the voltage is not very high, then you use DC to DC converter. Okay, because you need the devices to be compatible with the PV module power, otherwise it won't work. Okay, so because with DC batteries you can't charge your mobile phones, okay, because they need certain type of adapters for it. So এটা হলো ব্যাপার. So the power conversion is needed whenever you want power directly from PV modules. Power conversion is needed when you want power from energy chargers. Okay, both are. Then comes the applications. The application part is actually never ending. I've written 4 here, but the application part is never ending. You can use it for lighting, you can use it for pumping, you can use it for refrigeration. And one of the most important aspects of PV systems are the grid connection. So PV modules is one of the, like, the smart grid system bole arki. What is the smart grid system? Smart grid system means actually that the consumption, the power you are getting will be compatible with your consumption. Okay, আপনি যতটুকু কনজাম করবেন ততটুকু পাওয়ারই আপনার জন্য থাকবে। So PV is, if we enable to blend the PV power to our grid connection, then it will be very helpful. How it will be helpful? Suppose when it is a bright sunny day, you like, suppose you are creating or you are producing 200 to 300 kilowatt power in bright sunny day, but in your house you need only 100 kilowatt power in single day. Suppose it is just a number 100, so there are 200 kilowatts of energy that is saved. But during like this kind of day, this rainy day, the power output will be 0 kilowatt because there is absolutely no sun out there. So what you can do? What you can do that you need to build a smart solution. The smart solution is when you are having 300 kilowatt, that day you are saving 200 kilowatt of powers. Then you can sell that power to your grid connection. Okay, you can sell that power. But whenever it is a rainy day or cloudy day, then you can buy that power. Okay, those there এখানে এভাবে হলো হিসাবটা হয়ে যায় আর কি, ব্যালেন্স করাটা। So it is very important to know to understand the grid connection, how to blend your PV powers to the grid connection, because it is not very easy, because ন্যাশনাল গ্রিড একটা বিশাল ব্যাপার। যেমন এক সময় একটা কোন সালে জানি, এটা 2013 না 13 মনে হয়, 13 না 12, যে পুরো বাংলাদেশ ব্ল্যাক আউট হয়ে গেছিল। ঠিক আছে, একদম ফুল বাংলাদেশ ব্ল্যাক আউট হয়ে গেছে। তো এটা মানে ওই সময় কেন হয়েছিল, এটা অনেক কারণ আছে। যাই হোক, এগুলোর মানে গ্রিডে কানেকশন, টু connect with grid, it is very difficult because you need to maintain the frequency, you need to maintain the certain voltage, so it is not that easy. Okay, so a grid connection একটা বিশাল খাত আর কি, ঠিক আছে। So this is a complete idea of solar PV systems. These are the elements, these are the applications. So these are very important to understand how a solar PV system works. Now we go to some important part. Now we will understand a topic which will be the sizing of a PV cell. We'll understand the sizing of a PV cell. Sizing of a PV cell means that how much area you will need to install your PV cell. What does supposed to mean, sir? That's supposed to mean whenever you want to install some kind of PV cell on your roof, the space is not infinite. Space is infinitely long now. Space is not infinite. The space is very limited because real estate is very expensive. So the space in your roof is not, that much. So what you have to do, that you have to suppose if it was infinite amount of space, then we will have a long, very large solar cells on our roof, and we will use that solar cell to provide electricity in whole building. Then we will save thousands of our money. But we can't do it because solar cells comes with some kind of space. Okay, suppose some kind of area. Before installing a solar cell, you need to find that how much power or how much energy, how much voltage, how much current you are needing, how much it is you demand. With that demand, you have to design your area of that PV cell. Okay, this is imperative. This is the term. Now this is called the sizing of PV cell. মানে আমি PV cellটা সাইজ করব। দেখেন, if you remember before meet, we have talked about the cell efficiency or module efficiency. We've talked about it. There is a term called the cell efficiency or module efficiency. What is cell efficiency? Cell efficiency was output power divided by input power. I hope you guys are, these formulas are not, these formulas are not unfamiliar to you guys. I hope these are very familiar. The cell efficiency or module efficiency is the output power divided by the input power. And the output power is Vm into Im. Okay, Vm into Im, maximum voltage into maximum current. And P in, the input power, was solar insolation into area. ওই যে আপনাদের এরিয়ার ম্যাথ নিয়ে কত কাহিনী হলো, ওই যে আপনাদের আইডি দিয়ে ম্যাথ করতে দিলাম। So this is the solar insolation into area. Now the important part that is happening here is the solar insolation. Solar insolation নিয়ে এলো আমরা এখন কথা বলবো। How solar insolation works. In the previous terms, whenever we're discussing about the solar insolation, I have given you a certain value or a fixed value, suppose 1 kilowatt per meter square. Okay, 1 kilowatt per meter square. This was the solar insolation, and you multiplied it by area. That means the amount of power you are getting in 1 meter square. Now, that solar insolation is not always fixed, because the PV plate or the PV cell you are getting is not always perpendicular to the sun. সানের সাথে এটা 90 ডিগ্রি বা সরাসরি এটা আসে না, ইজ নট ডাইরেক্টলি, সান ইজ নট ডাইরেক্টলি পোরিং ইট আপন ইট, এটা সানটা সরাসরি এটার উপর পড়তেছে না। So writing a certain constant value is not always correct. Writing a constant value is not always correct, because sun can be directly above it, sun can be like this, sun can be like this, because the sun is directly above us when it is in the noon time, but during morning or during afternoon, sun is not directly upon us, it is rotated a certain amount of angle. So here comes the tricky part. Suppose if I draw the PV cell here, okay, এই যে এখানে হলো দেখেন, suppose this is my, I should draw it more tilted. Okay, suppose this is my 90 degree. This is the 90 degree term. Now, suppose sun is giving you ray from this angle. Okay, sun is here. So this is the solar insolation L. But you need to find the value that is directly or that is perpendicular to that solar cell. This L is not giving you the total amount of energy. This L or this sun is giving you a certain portion of its energy. So suppose the angle that sun is giving its solar light is theta. Now the portion here, the perpendicular portion here will be L, এখানে আমরা Li, this is solar insolation, will be Li cos theta. These are from the simple trigonometry. Okay, these are from the simple trigonometry. If you forget the simple trigonometry, then you need to remember it. মনে করতে হবে আবার, কিছু করার নেই। Simple trigonometry. Okay, যেমন এখানে যদি আমি আপনি রাইট অ্যাঙ্গেল ইয়া করি, simple trigonometry. So this is the Li cos theta. So the matter of, if I summarize what I'm getting, the formula you were using was Vm Im into L into A. But you can't use that formula anymore, because the solar insolation is not directly above our PV cell. A certain portion of solar insolation is on the PV cell. So this L will be replaced by the Vm Im. This L will be replaced by Li cos theta into A. So এই জিনিসটা এখানে বুঝেছি, Li cos theta into A. Okay, so এটা হলো ব্যাপারটা। Now it is the sizing of the PV cell. So the area is depending on the, you know, the geographical model. Area is depending on the weather. The area is depending in the which part of the world you are here, you are. So these are এখানে হলো এই ব্যাপারগুলো আসে। So efficiency VMIM, the thing you need to remember or you need to understand, we have replaced just one term here. We have replaced the term solar insolation with Li cos theta. Cos theta means the angle that is hitting the PV cell. Now what we do, we just cross multiply. Li cos theta will be multiplied by this, you know, efficiency term. এই যে দেখেন ক্রস মাল্টিপ্লিকেশন নিচে চলে আসলো VMIM এক পাশে। ওকে, তো VMIM হলো পিনট। সো A ইকুয়ালস টু কি হবে? A ইকুয়ালস টু হবে হলো আমার P নট ডিভাইড বাই ইটা ইনটু Li cos theta। P নট হলো VMIM হিসেবে আপনি you can use it interchangeably with VMIM. So this is the formula. From this formula I'm getting the A. A is equal actually the sizing of the PV cell. Okay, so P naught by eta into Li cos theta. So এই হলো ব্যাপারটা। So এখানে just the subtle difference from the earlier formula is that we are not considering the solar insolation to be exact. যখন দেখেন solar insolation is directly upon the PV cell or the sun is directly above the PV cell, that then what is the theta? একটু মাইক অন করে বলেন তো। আচ্ছা চ্যাটে লেখেন সবাই। If sun is directly giving us the sunlight on the PV cell, what is the value of theta?
0
সবাই
sir.
লেখেন। এই যে আপনাদের একজন বন্ধু কিন্তু 0 লিখে ফেলছে। ঠিক আছে, হ্যাঁ সুন্দর, 0 হবে। 0 হইলেই কিন্তু দেখেন ওই যে Li cos theta যে টার্মটা, ওই cos 0 ইকুয়ালস টু কি, cos 0 হলো 1, তখন কিন্তু Li হয়ে যায়। বুঝছেন? এই কারণে আমরা in the previous section, in the previous slide, we didn't consider to be a solar insolation to be any angle. We consider it to be 0 degree. That is why we didn't write. But now we have seen that the sun is not giving the rays directly on the PV cell. It is very natural. Whenever it is in the noon time, we get the sun just above us. But in all other time, we get sun, you know, we get sun in the different direction. That is why there is a project which is of the sun tracking or solar tracking. If you smart solar tracking একটা ডিভাইস ছিল, what that device do, ওটা খুব একটা ভালো প্রজেক্ট ছিল। Suppose this is your PV cell. What this PV cell, you have installed a motor here. So what this do, whenever sun is here, it rotates to this place. Whenever sun is here, it rotates. Whenever sun is here, it rotates. So the important part is you are getting the 90-degree angle always, but it is, you know, cumbersome. There is some controlling thing, so it is expensive. That's it. So I hope you guys understand the formula and the area of it, the sizing of PV cell. Now we'll do a small map from our handout. I am using different slides, different PDFs. So whenever you are recording to my lectures, make sure that all the components, all the materials are in front of you. Then it will be easier for you because all the materials are given on the BLC. Everything here is given on the BLC. You just need to find where, what is where. আচ্ছা দেখেন এখানে একটা ম্যাথ দেওয়া আছে। For designing a PV module for a house needing 250 watt power, solar insolation is 1 kilowatt per meter square, efficiency 25%. Okay, efficiency 25%. এখানে যদি আমি অ্যাঙ্গেল দিয়ে নিই, what will be the total area? If each cell is 156 into 156, how many solar cells will be needed? আচ্ছা দেখেন প্রথমটা করি, what will be the total area? We know that if efficiency VMIM divided by LA. In this math I didn't give any angle, but I can give any angle. I don't think it will be very tough for you. It will be the same, just there will be L into cos theta. So from this formula, we are getting the A equals to VMIM by efficiency into L. So area is equals to VMIM. VMIM is 250 watt. 250 watt. Then comes what? Then comes the efficiency. Okay. Efficiency is 25%. That means 0.25. Solar insolation is 1 kilowatt per meter square. That means it will be 1000 into 0.25. The total area will be what? It is the total area that the PV cells are here. Total area. Now I'm asking you, if each cell is 156 into 156, how many solar cells will be needed? This is the area for all the solar cells. So এটা কিন্তু একটা tricky formula, এটা কিন্তু tricky জিনিস. Suppose you have bought 100 টাকা worth of apple. কথাটা বুঝেন, you have bought 100 টাকা worth of apple. One apple costs you 10 টাকা. One apple costs you 10 টাকা. Then how many apples you have bought? Answer will be 10. কেমনে করছেন? ভাগ দিছেন. You have divided 100 by 10. So that thing will do it here. Area of a single PV cell. একটু দেখেন, আমি এখানে দেখাই. Area of a single PV cell is suppose A. Single PV cell. ঠিক আছে, single. বড় হাতারে এটা হলো total. N is equals to number of PV cells. Number of PV cells. Now I hope with your common sense you can write the formula or the relation between these three. What will be the relation? Total area is equals to single area into number of PV cell. এটা মনে হয় কমন সেন্স দিয়ে পারা উচিত সবার, এই যে অ্যাপেল অ্যানালজি থেকে বুঝতে পারেন। সো এখানে দেখেন এই জিনিসটাই করছে, এরিয়া অফ পিভি সেল, সিঙ্গেল পিভি সেল এ, নাম্বার অফ পিভি সেল n into a equals to a. So n equals to a by a, এই যে 1 by 156 150 10 to the power minus 6. I hope you know why 10 to the power minus 6 is there. Then the total number of PV cells is 41. So it is always safe for us to have increased amount than the less amount. Okay, it is always safe. So fraction value doesn't make any sense here, because আপনি কি একটা সেলকে মাঝখান দিয়ে কাইটা অর্ধেক করে লাগাই দিবেন সাথে, it doesn't make sense. So what we have to take, we have to take an integer value. So in order to take the integer value, you can do 41 or you can do 42, but we will accept the value of 42 because we will be better safe than sorry. Okay, আমরা safe থাকবো. So n equals to 42. So you can do the combination of 42 with different types of series and parallel connection. But if you do 8 into 5, that means 8 rows and 5 columns. 8 rows and 5 columns. Then it will be 8 into 5, 40. So 40 is not answer, it is 42. So in order to do the 42, you will do the nearest possible. It is not possible to get the exact 42. You will get the nearest value. Okay, nearest above value. So it will be what? It will be 9 into 5. 5 nom 45. We need 5 columns and 9 rows. There will be 45 cells. Because in the last part of the question, if we sort them, question again, if we sort them in rows, how many columns will be? If we sort them in 9 rows, 9 in the 9 leaks. If you sort them 9 rows, how many columns will be needed? Total PV cell number is 42. So 9 rows, that means 9, if I do the math here, then 9 rows, column equals to 42. So column will be what? 42 by 9. Okay, so এখন আপনি কি করতে পারেন এটা? ঠিক আছে, এটা হলো এটার ক্লোজ, এটা হলো 4 point something আসবে আর কি। So the integer value will be 5 আর কি। ঠিক আছে, 4 point something আসবে, এটা হলো টোটালটা 5 নেবেন। কোশ্চেনটা দেখেন, the question was that I have given the value of the rows as 9 rows, then how many columns is needed. এটা হলো কোশ্চেনটা ছিল সি নাম্বারে। সো এটা হলো এইভাবে বের করছি। So I hope everything is clear and I hope you have understood the topic today. Thank you everyone. This is the ending of the class.